Usually when you think about plugging something into a wall, there is this um, expectation of absolute simplicity.
Right.
It's a totally binary relationship.
Yeah, exactly. It just works.
Right, like you plug in a toaster, the coils get hot, you plug in a lamp, the room gets bright. You don't sit there and think about the power plant or the high voltage transmission lines. You just trust the outlet to do its job.
Well, we treat electricity like it's just magic hiding behind the drywall.
Yeah.
I mean, we've had a century to get used to the grid functioning mostly invisibly in the background.
But then you step into the world of global electric vehicle infrastructure, and suddenly that simple plug on the wall is like the center of an incredibly chaotic, high-stakes battle.
So welcome to your custom-tailored deep dive. Today, we are unpacking the invisible systems that are actually going to power the EV revolution.
It is a massive system.
It really is. And the stack of sources we have for this session is wonderfully eclectic. Like, we aren't just looking at one piece of the puzzle here. No, far from it. We are crossing between high-level industry forecasts and incredibly dense ground-level operational realities.
Yeah, we've got the 2026 Drivers predictions for the EV charging industry, a really deep global market report from Fact.mr on battery swap systems, and a totally in-the-weeds presentation from the California Public Utilities Commission, the CPUC.
Right, the ones specifically focusing on vehicle grid integration.
Exactly. And on top of that, we are layering in recent U.S. Department of Transportation policy updates, legal rulings involving the National Association of Convenience Stores, and even a draft infrastructure strategy out of Ireland. So our mission today is massive. You see EVs everywhere, but today we are unpacking the invisible high-stakes battle to actually power them. We're talking everything from multi-billion-dollar grid upgrades and AI management to literally geopolitical supply chain wars.
What's really fascinating here is that the transition to electric mobility is, well, it's no longer just about the cars themselves. I mean, the vehicles are practically the easy part of the equation at this point. What we were really talking about is rewiring the world's energy and geopolitical infrastructure from the ground up and, simultaneously trying to keep the lights on while we do it.
Okay, let's unpack this, because we really can't talk about building more chargers until we understand the immense, almost breaking point strain they're putting on the power grid.
It's a huge strain.
Looking at the CPUC presentation, specifically the electrification impact study from PG&E, the numbers are just staggering. California alone is facing between $23 billion and $32 billion in distribution grid investments by 2040, just to handle electrification.
Yeah, just to keep up with the load.
That sounds like we have to physically tear up the streets and build an entirely new power grid. But didn't the Drive report say AI is going to save us from having to do that? Like, using a super smart air traffic controller for electricity.
Right, so Drive is heavily champions AI as the mitigation strategy, yes. They point out that AI-driven energy management can optimize charging schedules and create virtual power plants, or VPPs, using vehicle-to-grid technology.
Let's break that down for a second. Because VPPs and V2G, they get thrown around a lot as buzzwords.
They do. But think about the actual mechanics. A virtual power plant using vehicle-to-grid technology means that thousands of plugged-in EVs aren't just drawing power.
Oh, they act like a battery.
Exactly. They act as a massive decentralized battery. So during a heat wave, when the grid is really struggling, bidirectional inverters allow the utility to pull a tiny bit of power from all those parked cars to stabilize the system.
Wow.
Yeah, and the software orchestrates this whole dance, balancing the load so we don't have to spend billions laying, thicker copper wire.
But wait, if the AI is acting as this perfect air traffic controller, redirecting power seamlessly, why is PG&E still staring down a $32 billion price tag for grid upgrades?
Because of the limitations of passive management and, frankly, the reality of human behavior.
What do you mean?
Well, the E3 presentation within that CPUC forum shows exactly why our current, quote-unquote, smart solutions are backfiring. Right now, we rely heavily on passive management, specifically time of use rates.
Oh, right. We've all been trained to use time of use rates. Like, the utility company makes electricity cheaper after 9:00 p.m., so everyone sets their cars to charge overnight to save a few bucks. It seems like the responsible thing to do, right?
It seems responsible until you look at the physics of the distribution grid.
Okay.
The E3 and integral analytics studies reveal that when you use static time of use rates Everyone's smart charger waits until the off-peak rate starts, say 9:00 p.m., and then they all pull power at the exact same millisecond.
Oh, wow.
Yep.
So instead of smoothing out the demand across the night, you just create a massive artificial spike the moment the clock strikes 9.
Exactly. They call it a rebound peak. And the toll it takes on the physical hardware is severe.
Huh.
I mean, these studies found that time-of-use rates are actually increasing peaks on over 20% of distribution feeders.
So it's making it worse.
Much worse.
Huh.
Picture a neighborhood transformer box. It was not designed to have 50 cars suddenly pulling 11 kilowatts of power simultaneously. The policy that was designed to save the grid is literally cooking the local hardware.
That is wild. We are overloading the local transformers by trying to be economically efficient.
Yep.
So if static time windows are actively breaking the system, what is the fix?
Moving from passive to active, location-aware charging orchestration.
Which means what, practically?
Instead of a generic time window for the whole state, the system dynamically throttles the power draw based on the specific thermal capacity of that single neighborhood transformer at that exact second.
Oh, I see.
Yeah, and PG&E estimates that shifting to this active orchestration can avoid those localized hardware meltdowns, which saves $1.8 billion in infrastructure upgrades.
But here's the part of the CPUC documents that actually made me do a double take. There's a silver lining here for the ratepayer. The math shows that if we get this active orchestration right, distribution rates could actually drop by up to 25%.
Which is huge.
Yeah, it's about 3.5 cents per kilowatt hour by 2040. But they have to spend up to $32 billion on upgrades, and yet our electric bills might go down. Make that make sense.
It comes down to volume and fixed costs. The total volume of electricity being sold is going to skyrocket over the next 2 decades.
Right.
And the grid itself, the poles, the wires, the substations, it has massive fixed maintenance costs. If you manage the load actively so you aren't constantly blowing up transformers and replacing melted hardware, you get to spread those fixed grid costs over a massively larger pool of kilowatt hours sold.
Oh, I get it. More volume pushed through a stable system means the cost per unit goes down.
Exactly.
That is the counterintuitive brilliance of scale. But it also relies on a flawless, perfectly orchestrated software system that feels, frankly, decades away from being fully implemented across every utility.
Very true.
And if you are running a fleet of delivery vans or commercial trucks, you can't wait for the grid to perfectly optimize itself by 2040. You have packages to deliver today.
Right. Commercial operators do not have the luxury of waiting.
Yeah.
They are finding ways to physically bypass the grid bottleneck altogether, which fundamentally shifts how we think about refueling.
And this leads us to the Fact.mr report, which dives into the global battery swap market. According to the data, we have hit a critical inflection point right now heading into 2026. This market is currently valued at $1.3 billion. But it is projected to grow at a massive 25.3% compound annual growth rate.
Rocketing to $12.5 billion by 2036.
Yeah.
The demographic breakdown in that report tells the real story, though. 62% of this massive market isn't driven by luxury sedans. It's driven by two-wheelers and three-wheelers, heavily concentrated in Asia, specifically China, India, and Indonesia.
So we're talking like mopeds, delivery scooters, auto rickshaws.
Exactly. The absolute backbone of urban logistics in those regions. Giants like Amazon, India, and Flipkart are pushing this because of, charge wait downtime.
Right.
For a delivery driver, making really narrow margins sitting at a charging station for 2 hours is disastrous.
They lose money.
Yep. Battery swapping changes the equation entirely. We are looking at sub-3-minute swap times. You pull into a kiosk, pull out the depleted battery, slot in a fully charged one, and you are immediately back on the road.
Okay, here's where it gets really interesting. The report details a massive shift happening right now in the business model of these swapping stations. For years, this was dominated by proprietary walled gardens. Like you buy a brand X scooter, you have to use a brand X swap station. But fleet operators are rebelling against that. They demand standardized swappable packs. So is this basically like the EU forcing tech companies to use USB-C, but for vehicles?
That is a perfect parallel, yes. Fleet operators buying thousands of vehicles just refuse to have their entire operational infrastructure locked into one manufacturer's ecosystem.
Makes total sense.
They need interoperability to scale. That's why open format suppliers like SCN Mobility in India and Ample in the US are gaining such massive ground. They provide the universal standard, the USB-C of batteries.
And from an engineering standpoint, the report notes that lithium iron phosphate, or LFP chemistry, holds a 50% market share in these swap networks. Why LFP over the standard lithium-ion batteries we have in, say, our phones or laptops?
Well, it comes down to sheer durability and thermal stability. In a high-frequency swap environment, these batteries are being fast-charged constantly, handled roughly, and exposed to extreme temperatures.
They take a beating.
A massive beating. Standard lithium-ion chemistries can degrade or even pose a fire risk under that much thermal stress. The chemical bonds in LFP cells are physically more robust. They can safely handle over 3,000 deep charge cycles without significant degradation.
Wow, 3,000.
Yeah, which is what makes the economics of a shared, constantly circulating battery fleet actually viable.
But, you can't exactly easily swap a battery on a 10-ton delivery box truck. For heavier vehicles, physically bypassing the grid with a 3-minute battery swap just isn't an option. So how do logistics companies handle the grid bottleneck for their heavy fleets?
They basically shift the burden to someone else. The Drivers Report highlights the explosion of charging as a service, or CaaS.
Because installing heavy-duty fast chargers for a fleet of 50 box trucks is an absolute nightmare. Right? We are talking about massive upfront capital expenditures or CapEx.
The physical reality of installing fleet charging is brutal. I mean, a logistics company suddenly finds itself having to negotiate with the local utility for grid interconnection, trenching up concrete in their depots to lay high-voltage lines, and navigating years-long permitting processes for new switchgear and transformers.
Yeah, they're a delivery company, not an electric utility.
Exactly. So under the charging-as-a-service model, a third-party company steps in and says, we will handle all of that. They cover the heavy upfront CapEx, they trench the concrete, they deal with the utility.
Okay, so what does the fleet operator do?
The fleet operator just pays a monthly subscription fee per vehicle or per kilowatt hour.
It fundamentally changes the risk profile.
Completely. It allows a delivery company to remain a delivery company, rather than forcing them to become experts in commercial electrical engineering. They turn a massive, unpredictable capital risk into a predictable operational expense, or OpEx.
It's like the cloud computing model applied to physical electricity. You don't build the server farm, you just rent the processing power.
That's exactly what it is.
But whether we are relying on AI software to act as an air traffic controller for the grid, or standardizing battery swaps in New Delhi, or using third parties to build heavy fleet infrastructure, someone, somewhere, has to physically manufacture all of this hardware.
Right.
And this is where the plug on the wall suddenly stops being an engineering challenge and becomes a fierce geopolitical battleground.
Yeah, if we connect this to the bigger picture, the physical charger itself is no longer viewed merely as an appliance. It is now classified as a critical piece of national security infrastructure.
This is perfectly highlighted by the U.S. Department of Transportation press release we have in our stack today. And just to be clear to you listening, our goal here is to impartially look at the policy mechanics and the supply chain realities, entirely separate from the politics.
Absolutely.
So the current Trump administration, via Transportation Secretary Sean P. Duffy, has issued a sharp critique of the previous Biden-Buttigieg administration's EV charger program, essentially labeling it a failure. And alongside that critique, they've announced a massive, immediate policy shift. They are expanding the Buy America waiver from 55% to 100% domestic content for any federally funded EV chargers.
And the reasoning behind this shift extends far beyond traditional arguments about, domestic job creation or boosting the industrial base. The administration's stated goal leans heavily into national security.
Really?
Yeah, they are explicitly aiming to prevent foreign adversaries from supplying components that end up embedded in the national charging network.
Because a Level 3 fast charger isn't just copper wire and a plastic casing, it's high-voltage power electronics and specialized semiconductors. Is the fear actually about hacking?
Absolutely it is. Think back to the vehicle-to-grid and virtual power plant concepts we discussed earlier.
Right, the two-way communication.
Exactly. If millions of cars are actively communicating with the grid, drawing and pushing power dynamically, that communication network is a huge potential vector for attack. The threat model suggests that foreign-made microchips or software components could contain cybersecurity vulnerabilities.
Oh, wow.
If an adversary exploited those, they could theoretically manipulate the power draw of thousands of chargers simultaneously. which could disrupt local or even regional power grid frequencies.
That is terrifying when you realize these chargers are actively managed, two-way nodes. But mandating 100% domestic parts, I mean, the sheer friction of that in a deeply globalized supply chain has to be immense. You can't just source every semiconductor, cooling system, and transformer coil domestically overnight without grinding manufacturing to a total halt.
The friction is immense, yes, and it's causing legal and operational turbulence right now. The National Association of Convenience Stores, or NACS, provided documents detailing a recent federal judge ruling.
Okay.
The judge ruled that the suspension of the NEVI program, the National Electric Vehicle Infrastructure Program, was actually unlawful.
Oh, so while the supply chains are scrambling to meet these 100% domestic mandates, there are actual legal battles freezing the rollout of the federal funding meant to build the network in the first place.
Exactly, and this struggle to get steel in the ground is a global phenomenon. Look at the draft National EV Charging Infrastructure Strategy from Ireland.
What does that say?
The government there flatly acknowledges ongoing, quote, infrastructure gaps and the critical need for significant capital investment. The reality of building physical infrastructure is incredibly messy, it's slow, and it's increasingly caught up in international trade policies and security mandates.
Right. So if you are a commercial fleet operator, you're watching the local grid struggle to handle the electrical load, and you're watching the supply chain for chargers get tangled up in 100%. Buy America mandates, lawsuits, and cybersecurity fears. What do you do?
You build a hedge against the uncertainty.
How so?
Well, the driver's report points to the rising trend of multi-fuel hubs. We are seeing commercial stations that refuse to rely solely on the electric grid. They're integrating hydrogen refueling alongside EV fast chargers, particularly targeting heavy-duty and long-haul fleets.
Oh, I see. It's an operational safety net.
Yeah.
If the grid is strained, or if charger deployments are delayed by a year because of supply chain restrictions, having hydrogen on-site allows the logistics companies to ensure their heavy fleets keep moving regardless of what happens to the electrical infrastructure.
Exactly. It's about resilience.
So what does this all mean? We started this deep dive by talking about the absolute simplicity of plugging a coaster into a wall. But behind that plug, there is a staggering $30 billion grid challenge that is forcing us to use active AI orchestration just to prevent neighborhood transformers from catching fire.
Yeah, quite the shift.
And we've got commercial fleets driving a USB-C-style standardization of battery swapping across Asia to bypass the grid entirely. We have third-party services fronting massive capital to trench concrete for heavy truck chargers. And overlaying all of this is an intense 100% Buy America mandate driven by the very real fear that a charger is actually a Trojan horse computer capable of taking down the power grid.
Which really raises an important question, and it's a profound shift in how we view transportation.
Okay.
If our cars and our chargers are no longer passive devices, if they're becoming actively managed, two-way nodes that are absolutely critical to the daily survival of the national power grid, and if foreign parts are being aggressively banned specifically for cybersecurity reasons, at what point does an EV stop being a personal vehicle and start being classified and strictly regulated as a piece of national critical infrastructure?
Wow. That is a wild thought to leave on. The next time you walk past a charging station or, even just